Hello friends. Today I have created a three-tier architecture web service which is dependent upon Aquila CMS, and I have made this project on AWS web service. Okay, so let me take you to the diagram first. So this is the full-length diagram of which I have created. Now this is a three-tier architecture diagram. Okay, so there will be two public subnets. This is public subnet 1, this is public subnet 2, and as well as there will be two private subnets, that is private subnet 1 and private subnet 2. So application tier will be dependent upon public subnet 1 and database server is dependent upon private subnet 2. Now we cannot reach private subnet 1 and private subnet 2, but the user can reach through internet gateway and reach to the front-end server. So when a user hits this 13.201.7.163 IP address, he will reach this web page. Now the user can access the front-end server, but user cannot access the private subnet 1 and private subnet 2 because there is no direct connection over there. Now, so this is the first tier, the front-end server. This is the second tier, which is application server, and this is the third tier, which is database server. Now application server runs the application, so main code runs in this server. Now let's take you to the AWS console. So first I have done VPC creation. So let me take you to the VPC creation page. It will take some time. Okay, so we this is the VPC console page. Now let me take you to the VPCs. Okay, so this is the main VPC which is available on available with the AWS console. But if we want to create private subnet and public subnet separately, so we have to create a custom VPC. So I have created a custom VPC. So let me take you to the resource maps where we can see the diagram. So this is the VPC. Now what I have told you, that is, this is a public subnet 1 and public subnet 2 and private subnet 1 and private subnet 2. Now let me take you to the subnets. So you can see that on AP South 1A I have created one public subnet, as you can see this, and one private subnet on AP South 1A. Okay, and on other hand in AP South 1B, I have created a public subnet and a private subnet. Now, if I hover over the public subnet, you can see the route tables also. So this public subnet reaches to the custom route table, which is public, and it is connected through a internet gateway. But the custom private subnets are not connected through the custom internet gateway. Why that? Why? Because we don't want that users are connect through private subnet. So the private subnets are connected through custom private route table, and I am going through that. I will go through that. So just forget now this NAT gateway. I will come to that later. Now, this is private subnet 1 and this is private subnet 2. So these two are connected through different route tables. At this time, just forget NAT gateway. So now this public subnet, private subnet 1 and private subnet 2 are not connected through the internet. So how can we acquire the internet, which is like through NAT gateway, right? So just forgot that. Just forgot the NAT gateway part right now. Okay, so let me take you to the EC2 console. Let me take you to the first EC2 console, because I have created the applications, web servers. So let me check that. Okay, let me edit it a little bit. Okay, so as you can see, this is the front-end server. You can see that this is a front-end server, right? So front-end server is upon public subnet. So that means front-end server can an user can access the front-end server by internet gateway, but he can not by okay, sorry for that. So an user can access the front-end server IP address by 13.201.7.163, which is this one, right? And obviously the server will have some private IP address. Now let me take you to the application server. So this is the application server. As you can see, application server does not have an IP address, public IP address, but he has a private IP address. Just you can see that So 10.0.13.115. 10.0.131.115. This is the private IP address of application server. But there is another private IP of DB server, that is database server. So on database server, this is the private IP address. Now I have created these applications in AWS, and the application server, the instance type I have used for application server is t3.small, because in application server there is more resource needed. Okay, so let me take you to the application. So this is the final product. Now let me take you to the terminal. Okay, so as you can see, this is the front end server. I just open the htop, the memory utilization, just seeing the memory utilization. So let's just kill it. Okay, so as you can see, this is the front end server, this is the application server, and this is the database server. So now the question is, how can we reaches these app server and database server? Because we cannot just enter the application server and database server, because those are on private subnets, right? Private subnet 1 and private subnet 2. So how can we enter the private subnets? I mean private subnet application, sorry, private subnet server. So you can see that we already connected in application server. So let me just exit from this. When I exit, you can see that this is the front end server. What? Really? Okay. Just go to database server and let me try exit one more time. Wow, this is the front end server. So how we connected DB server from front end server? That is the main department where we can go with Bastion Connect. So this front end server will also act as a Bastion server, right? So you can see that these servers, front end server, application server, and database servers are connected in a VPC. That means let me take you to the VPC console once again. So this is the custom VPC. Now you can see the CRDR range. So 10.0.0.16. So you can see that the ranges lies between same, right? So we can ping from front end server to the application server, and application server to DB server, and DB server to front end server. Let me check you to that. Ping. Now which are the application server IP address? This is the application server IP address. Let me copy this and just paste it here. Sorry. As you can see, we can ping. Okay. So the private IPs are connected to each other. So by Bastion Connect, we can connect a private subnets server. But other than this VPC, we cannot connect these private subnet servers. That's why an outside user cannot connect the public server. I mean, private subnet servers. Now, so this is the front-end server. This is the application server. Let me Bastion connect once again. So SSH -I bastion.pem. This is the PEM file by which we can connect with the application server, and Ubuntu this is the username, and this is the IP address of Ubuntu server. Let me just connect that. So we can now connect to the application server. Let me try to connect the DB server as well as. Okay, and connect the DB server. Now here in DB, we just installed MongoDB. Okay, and after installing MongoDB, you can see that we have to configure the MongoDB configuration. So cd/etc and vi mongo.conf. So I just edit this bind IP to 0.0.0.0. That means this MongoDB will configure for any IP address. So any IP address can any IP address can use this MongoDB. Okay. Okay. Now let me take you to the application server. So in application server, you can see the Jenkins also. So I will come that in later part. So I have just used this GitHub profile. That is my GitHub account. That is mix page. And after that, I just copy this and just do that git clone and this. Okay, so I will not do that right now because I have already done that. So I will get this Aquila CMS application, which is a Git repository, is a repository. So I will go to the Aquila CMS right now, and if I do ls, so I will get the existing packages and scripts and yarn.log and all those things which are required to run the application. Okay, Now, if I just do docker compose up, so you can see that here is a docker file. So I have used this Aquila Linux, this Linux for the base image and all those things for docker file. Now, okay, let me take you to the Jenkins right now. Wait. So I have configured, sorry. Okay. So I have created this pipeline for CI/CD purpose. So first it uses the pipeline syntax. So first this will go through an agent. So in agent, it will find the node which has a label of web. Now where is the web label? Let me take you to that as well. If I go to the nodes, and you can see that we can have the web. Now what is the web? I just take this app server nodes for this. Let me check you that also. You can see the host IP address 10.0.131.115. So let me check this also. What is the IP address? The IP address is 10.0.131.115. So you can see that the application server IP address is also the same, 10.0.131.115. Now let me save that. So the label name is web. So I have just used that label for this. So in the first stage, I will just clone the Git. Now this is a step to clone the Git branch as a main branch, and I gave the URL. Next step is build the Aquila, right? So there is a Docker file, as I show you. This is the Docker file, and the Docker file builds the image, right? So this is building the Docker image. Now I have to log in to the Docker Hub and pushes the image to the Docker Hub repository. So this is the Docker Hub repository. So with credentials, I have already saved these credentials earlier. Let me check you that also. Let me duplicate it, and I can see you on Manage Jenkins, and you can go to credentials. So you can see that Docker Hub cred. So this is the Docker Hub credentials. Now, the this is the syntax of how to use Docker Hub credentials. Now, after that, after with this block, you can see that the block is started on this way, and it stops on this. So I have used sh for shell command. I have used shell command and used docker login -u and environment dot user. So this user is came from this user environment variable user, and the user will be reflected as mix veg. Okay. After that, I have used the password as variable pass. So env.pass is goes through the password, right? And again Docker will tag the Aquila image which already built on Aquila, and after that this will tag to mixveg / Aquila :latest. After this step, it will push to the Docker Hub repository. At the last stage, this will compose the Docker and Docker compose down. So the previous build will goes down and fresh build will up. So Docker compose up, and -d is for detachable mode. Now let me save this, and I have already used several times, tried several times, and just goes I'm going through some error. So I have just used my knowledge and just correct that. So at last we got this web server. Now I have some key achievements of this by doing this project. So this is deployed on a AWS infrastructure which is designed as a scalable infrastructure, which where I have utilized custom VPC with public and private subnets for optimal security, right? So I have reduced the downtime because I have used the cloud service, and as well as the two subnets. I mean, the in front end servers goes on subnet 1, and not subnet, on availability zone 1. You can see here these front end servers and application servers are on AP South 1A, which is availability zone, different availability zones, and the DB servers on 1B. So that improves in fault-tolerant architecture with redundancy through NAT gateways. Okay, so I forgot the NAT gateway, right? So at first I said that the application server cannot connect to the internet, but we can attach NAT gateway for internet connection. So in NAT gateway, no user can go through this NAT gateway, but only the servers can go through this NAT gateway. So NAT gateway is one-way communication, not as IGW, because IGW is, internet gateway is a two-way communication, established two-way communication. But in case of NAT gateway, that is a one-way communication. So by this NAT gateway only, we can connect to the internet. Okay. So by NAT gateway and multi-zone availability, we can access the internet connection and fault tolerance ability. So for security, I have enhanced the security by isolating application and database layers in the private subnet, ensuring no public exposure, and enabling internal only access to the private IPs. And after that, you can see here is the public subnet front-end server. So in front-end server, I have installed Nginx. Okay. So in front-end server, I have installed Nginx for reverse proxy. I will show that. Let me connect this once again. Okay. So you can see that sudo system ctl status nginx. You can see that Nginx is running on port 80, and okay. So I will go to the Nginx. So /etc Nginx configuration page for configure the Nginx for reverse proxy. So I will go to Nginx cd Nginx, and I will go after that sites available page, cd sites available, and you can see here a default file. So if I do cat default, you can see the server name is 13.201.7.163, which is the public IP, of this. Now in the location, I have give the proxy path as HTTP 10.0.131.115:3010. So 3010 is the port number of Aquila CMS. Okay, so you can see that the application server IP address is 10.0.131.115, which is this one, and after that I have used 3010. Why 3010? You can see the Docker file also. So in the Docker file, you can not see in the Docker file, you can see on the compose.yml. So yes, so the compose.yml, you can see that the background application is running on 3010. You can see that this is 3010. So the application is running on port 3010, and I have merged this port to host IP address 3010 port. Okay. So I have just used this script for reverse proxy. Nginx reverse proxy. So Nginx is in the front end IP address and just showing the application servers front page. So I have used the Nginx for reverse proxy, and I have used MongoDB for integrated database server. So this deployment optimized the Aquila CMS platform, which is the um, e-commerce application for high traffic, improved security, and provided a robust and fault-tolerant environment ensuring business continuity. Okay, so this is my three-tier architecture application. Thank you and have a great